process failure model. If we look back to the specification of a service, we have covered now the correctness properties in the interface. Now we are going to look to the model, distributed system model. And what we are going to talk about now about assumptions on failure. Model assumptions. Specification need to specify the distributed computing model, which are assumptions we need for the algorithm to work correctly. The model includes assumptions on failure behavior of processes and channels, and timing behavior of processes and channels. In this unit, we are going to look to failure behavior of processes. So processes may fail in 4 different ways: crashing and then stopping computation, omitting messages, crashing and then recovering later, or behave in an arbitrary way. For all these categories, we say that the process is faulty. And processes that do not fail in an execution, we say that the process is correct. So crash stop failure. Processes stop taking steps. So they don't do any computation, no internal events, no internal actions. They do not send messages, so no output actions, and they do not receive messages. Our default behavior of a process in this first part of the course is the crash stop. So we will be writing algorithms for the crash stop model. Hence, these systems do not recover. But processes are not allowed to recover. You see, we are going to assume a fixed set of processes in this course. And this assumption is unrealistic, since eventually, in due time, all processes will fail. However, if we are allowed to replace the set of processes by adding new processes, we can handle this problem. Adding new processes or configuring the set of processes running an application or a service is called dynamic reconfiguration. And we will address dynamic reconfiguration in part 2 of this course. Now let us turn our attention to omission failure. So a process omits sending and receiving messages. Some systems or some models differentiate between send omission, which is not sending the messages the process has to send according to the algorithm, and receive omission. We're not receiving the messages that the process is supposed to receive according to the algorithm. For us, omission failure covers both types. Crash recovery failures. In this situation, a process may crash and recover later. By crashing, it stops taking steps, and like for example computation steps, and stops receiving messages or sending messages. It may recover after crashing, and in this case we generate a special event we call special recovery event. It's automatically generated, and the process restarts at some initial recovery state. Normally, algorithms with a crash recovery process failure mode have access to a stable storage. And in the stable storage, it is used to store critical part of the state. So these algorithms may read and write to the permanent storage device, which is expensive. Many of these algorithms have to minimize the number of reads and writes to the permanent storage. And the idea is that the storage, the permanent one, will survive crashes, and it can be reused to restore a critical part of the state that we need for the algorithm to continue. So what happens in many of these systems is that you save the state to the storage, you crash, you recover, and you read the saved state. And from there, you continue with the recovery procedure. So what is a failure of a process in the crash recovery model? Failure is different in crash recovery model from the crash stop model. So we say that a process is faulty in an execution if it crashes and never recovers, or it crashes and recovers infinitely often, so it is unstable process. In this case, we say that the process is faulty. Hence, a correct process may crash and recover as long as the number of crashes and recoveries are finite. So a correct process in this system may crash and recover finitely many times. Okay. Byzantine failure is the most general kind of failure. Byzantine or arbitrary failure has the following behavior. A process may behave arbitrarily, for example, sending messages not specified in the algorithm, updating its state in a way that is not specified by the algorithm, or crashing. That's also. But also it may behave maliciously by attacking the system, and several malicious Byzantine processes may collude.